Hello, my name is Courtney Highland, and this is my unit of study focusing on forces in motion. The goal of educational programs should reflect a defined need and aim to change behaviors in learners. Curriculum specialists uncover the needs of learners and organize curriculum in a meaningful way to maximize experiences for learners. Curriculum may be defined as a construct or concept, a verbalization of an extremely complex idea or set of ideas. Instruction encompasses interactions between learners and teachers to facilitate the achievement of instructional goals and objectives. Curriculum and instruction may be illustrated by the cyclical model. The cyclical model depicts how curriculum continuously guides instruction. Instruction, in turn, provides necessary feedback to modify curriculum. The inclusion of STEM in curricula is a popular trend in recent years. The United States encourages an integrated STEM curriculum to engage youth in competitive global professions, such as in the fields of technology and engineering. Sanders stated that STEM purposely combines technological design with scientific inquiry, engaging students or teams of students in scientific inquiry situated in the context of technological problem solving. Policies have been instituted in recent years to encourage the integration of STEM in school systems across the country. In the state of Florida, science standards require that fourth grade students explore the fundamentals of physical science by studying forces in motion in the natural world. A unit of study has been developed for implementation at a magnet school for engineering and mathematics with fourth grade students. The Forces in Motion unit of study will address the need for the integration of STEM in schools nationwide. Constructivism serves as the theoretical base for the Forces in Motion curriculum, and experimentalism serves as the philosophical framework for the Forces in Motion unit of study. The unit's goals, objectives, learning activities, and assessments are aligned to encourage long-term transfer of goals. The constructivist theory supports active learning and high levels of interaction among learners. Constructivists support creative, active learning strategies that contribute to a student's learning experience. Vygotsky, a key contributor to constructivism, believed our brain proves to be an organ that retains our previous experience and facilitates the reproduction of this experience. In a constructivist learning environment, learners are encouraged to explore, discuss, and reflect on problem-solving activities. Creating active learning opportunities for students makes it easier for them to connect to the real world. This unit of study focuses on physical science concepts and uses active, cooperative learning to help students make meaning of abstract science topics. The Forces in Motion unit allows students to explore and discover concepts with the guidance of their teacher and peers. Students' high level of exploration in this unit encourages them to construct their own meaning of physical science concepts, a primary component of constructivism. Experimentalism serves as the philosophical framework for the Forces in Motion unit of study. Experimentalism is built on the philosophy that learning cannot occur without expanding our prior knowledge and creating new experiences. The Forces in Motion unit of study allows for students to interact directly with their environment and learn from real-world activities. Dewey noted experiences take place when a learner is interacting with things in their environment at a specific time. When an instructor creates real-world learning experiences for their students, they are more likely to solve problems outside of the classroom. Essential questions will be used to guide students' thinking and inspire them to solve real-world problems. Dewey believed an ideal unit of study will aim to create experiences, incite interest, and allow students opportunities to discuss knowledge in a social setting. Students will work collaboratively in this unit to discover how forces in motion affect objects in the natural world. The fourth grade Forces in Motion unit consists of 3 primary curriculum goals, developed based on the aims of education for the school in which it will be implemented. The curriculum goals are that students will recognize foundations of physical science, including forces in motion, examine foundations of physical science and apply them to real-world situations, and create a product that demonstrates mastery of physical science concepts and applies them to the real world. 4 curriculum objectives were developed to support the achievement of curriculum goals. All of these objectives will be measured with 75% accuracy. Students will define vocabulary terms related to force and motion. Students will describe how forces and motion affect objects in the real world. Students will interpret speed and distance of objects. And students will design a product to demonstrate understanding of forces and motion. Here's an overview of the instructional goals for the unit. You may notice that these goals increase in cognitive complexity as we move through the unit, using verbs such as recognize, investigate, interpret, and raise questions. Here is an overview of the corresponding objectives that will assist students in reaching the instructional goals, as well as curriculum goals and objectives. The verbs in the first part of the unit are a lower level complexity, describe and identify. However, as we move through the unit, calculate, select, design, and test and assess are higher level cognitive goals. The first instructional goal is that students will recognize that an object in motion always changes its position and may change its direction. There are 2 objectives associated with this goal. They measure as a level of understanding on Bloom's taxonomy and are a knowledge goal. The essential questions are: what are the relationships between mass, force, and motion, and how can an object in motion change its position but not its direction? Instructional strategies associated with this goal will be to write definitions, complete a Venn diagram, draw pictures, watch simulations, and test marbles traveling down ramps. The assessments include completing a pretest, the triple Venn diagram, the descriptions in their STEM notebook, and a completed marble worksheet with 75% accuracy. Instructional goal number 2 is that students will investigate and describe how the speed of an object is determined by the distance it travels in a unit of time, and that objects can move at different speeds. There are 2 associated objectives with this instructional goal, both still on the understanding level in Bloom's taxonomy and also a knowledge goal. The essential questions are: what information is needed to determine the speed of an object, and can you describe how objects move at different speeds? These essential questions will help guide students towards achievement of the instructional goals. Here are the associated instructional strategies and assessments with instructional goal number 2. Students will watch a simulation, make predictions, the teacher will model how to take notes, and students will test the marbles traveling down ramps in cooperative groups. The assessments include drawing an example in their STEM notebook and describing how an object's speed is determined by the distance it travels, writing predictions in their STEM notebooks, and writing a paragraph describing how speed and distance impacted the marble on the ramp. Instructional goal number 3 is that students will interpret the speed of an object by the distance it travels in a unit of time and examine objects' movement at different speeds. There are 2 objectives associated with this goal. Students will calculate the distance an object travels at different speeds and describe what forces occurred to impact speed and distance. These are Bloom's taxonomy levels understanding and application, and they are both knowledge and skills goals. The essential questions are: how can you determine the speed of an object in motion? And can you describe what forces impacted the speed and distance of the marble? The associated instructional strategies are modeling, practice problems, calculating speed and distance, drawing pictures, labeling, and explaining in a paragraph as to how forces impacted speed and distance of a marble. The assessments will be the calculations on the marble worksheet and the pictures, labels, and explanation in their STEM notebook with 75% accuracy. The final instructional goal is that students will raise questions about the natural world and conduct investigations to generate appropriate explanations based on those explorations. There are 3 objectives associated with this instructional goal. They will select a real-world situation where forces in motion impact society. They'll design an energy efficient car to travel a long distance using forces in motion to their advantage, and they will test and assess the success of their design. This goal is achieving different levels on Bloom's taxonomy as well as Krathwohl's affective taxonomy. Students will also be making meaning and transferring knowledge. Essential questions are: how do forces in motion affect my everyday life? How will I design a car that uses forces in motion to its advantage? And what forces in motion affected the outcome of my car? The instructional strategies will be a PowerPoint presentation, the outline of the car worksheet, and a rubric, showing students examples of designs from previous years and discussing them, reviewing the rubric, group expectations, and roles, and using guiding questions to facilitate learning while students are designing their cars. The assessments will be to write the real-world situation in their STEM notebook and complete the car worksheet and car design activity with 75% accuracy. The Forces in Motion unit incorporates STEM concepts and established need in the United States. The need for STEM education drove curriculum goals and objectives, eventually leading to the instructional goals, objectives, associated assessments. Curriculum goals support the state of Florida's 4th grade physical science standards. The curriculum objectives assist students in achieving the curriculum goals and are written using measurable terms. Instructional goals and objectives within the unit of study are connected to the curriculum goals, which is the goal of any educational program. Authentic assessments, such as writing assignments, design outlines, and final products, will be used to evaluate instruction. Formative assessments will be utilized throughout the unit to monitor students' progress towards instructional goals. All these strategies and assessments are aligned with the constructivist theory and experimentalism framework. The CIPP model is used to evaluate the Forces in Motion curriculum unit. This model was created by Daniel Stufflebeam, who described his CIPP model as a comprehensive framework for guiding formative and summative evaluation of projects, programs, personnel, products, institutions, and systems. The CIPP model illustrates 4 main components of curriculum evaluation that include context, input, process, and product. Context evaluations may reveal the need for a curriculum with integrated STEM concepts. Teaching staff will use input evaluations to meet the targeted needs of students. Process evaluations will assist teachers in planning and delivering instruction and evaluating unit success. Product evaluations will assess the achievement of curriculum goals and the success of a unit by using the students' products at the end of each instructional goal. Information gained from this evaluation plan will be used to modify and improve upon the curriculum. The physical science unit, focusing on force and motion, reinforces STEM education in K through 12 schools. The theoretical foundation for the Forces in Motion unit are connected to the constructivist theory. Students will work collaboratively to explore and develop their own meaning of the science material. Experimentalism is the philosophical framework used to develop the Forces in Motion unit. Instructional strategies were developed to create meaningful, real-world experiences for students. The aim of education guided the development of these curriculum goals and objectives. Instructional goals and objectives are aligned to the curriculum using a variety of assessment strategies. The unit of study will be evaluated using the CIPP model, which is continuous and proactive. The backwards design ensured that the unit was organized effectively and efficiently, allowing students to delve deeply into physical science concepts. Thank you for your attention during my presentation. And here are some references that were used in the development of this presentation.